Agenda for this evening. And so good evening. I'm happy to be here for the 10th DifferenceMaker Francis College of Engineering Prototype competition. So my name is Jim Sherwood. I'm the Dean of the Francis College of Engineering. This competition was designed to promote and recognize innovation within the within the college. So this year we received 23 applications and we had 13 projects presented tonight. So tonight you're going to hear from, in this session, the top 5 teams who were chosen earlier this evening to compete for $5,500 in prizes. Each team will have 5 minutes to present their idea, followed by 5 minutes of questions and answers by the judges. After all 5 teams have presented, we will have a 30-minute intermission while the judges determine the first, second, and third place winners. Around 8:30, the judges will return and the winners will be announced. We know from previous competitions that teams will continue to do great things. For example, in Visaware, a safety jewelry application won the Francis College of Engineering Prototyping Competition in 2015 and the DifferenceMaker Innovative Technology Solution Award in 2016. With their funding and additional DifferenceMaker support, they have reached over $15 million in sales. Go ahead, stand up, Raisha. Let's have a applause for you. So they have an office space in Lowell and employ 17 people. They've also been featured on various news stations like WCVB and Fox 25 for saving lives.
And
Additionally,
30 under 30. 30 under 30.
Additionally, they partnered with ADT, the national leader in security, and they have also been featured on QVC. We are excited to have Raisha, the CEO and founder, as a judge this evening. She and her partner, Ray Hamilton, were just awarded Forbes 30 Under 30 Award. Congratulations. So our students go on to do amazing things. Another past winner of DifferenceMaker's Idea Challenge and the College of Engineering Prototyping Competition, Ambulatory Innovations, pitched and won the regional competitions against Harvard, MIT, BU, and Northeastern. Additionally, they are currently working with UMass Lowell's Nerve Center to develop and test their prototype, a map to help physical therapists treat their patients by simulating outdoor terrain. Lastly, they have several patents pending to protect their product. And now I would like to thank everyone who has joined us here this evening. Before we get started, I'd like to recognize all of the DifferenceMaker faculty fellows who act as ambassadors for the DifferenceMaker within their colleges and departments. These faculty members help mentor student teams and prepare them for competitions like this. So a special thank you to the Francis College of Engineering faculty fellows, Dr. Carter Keogh. Carter, are you here this evening? And Dr. Khalil Wallace. Is Khalil still here? So I'd also like to thank the DifferenceMaker team, Holly Lalos, who was hiding over here somewhere, David Balatero, this fellow and the Risk Co-ops, Maddie, Alexa, Cameron, and Nick for collaborating with the Francis College of Engineering. As well as Sally Washburn, the Sally right here, Senior Director of Development for recruiting these amazing judges that we have here tonight. I'd also like to thank Paulette Bruno Brooks for coordinating this great event. Unfortunately, Paulette is not able to be with us this evening, but Tom Duggan stepped up and he was the guy who was up here for a few minutes trying to get these presentations loaded. So Tom, where did you end up hiding? He's way in the back. So now I'd like to thank the preliminary judges. So has anybody been advancing these slides for me?
It's automatic.
It's been automatic,
It's
okay.
automatic.
So we went right past them?
It's looping through.
Okay, here we go. So now I'd like to recognize the panel of preliminary judges who scored all the semifinalist student teams and provided them with feedback earlier this evening. So I'll read all of the names and then you can applaud at the end. So David Cohen, if you're here, please stand up and if you're able to, and keep standing up so you can be recognized. Dan McCormick, Kevin Kalish Desmond, Bill Percibelli, Steve Geister, Dave Janizek, Bob Finland, Joanne Movrades, Ken Horton, John Movrades, Beth Haskell, Mike Ryder, Tim Looney, and Jim Biggins. Thank you very much. So next I'd like to welcome the final round judges. So Chad, and please stand when I say your name. So Chad LaFrance, Director of Technical Excellence and sponsor of our third place prize tonight. Ram Sudareddy, CEO and co-founder of Benfield. Greg Sidney, Senior Managing Director of Capital and Companies. Cindy Condi, CEO of Condi Company. And Raja Abdelaziz, CEO and co-founder of Envisionware. So, over the next hour, you will hear our 5 student teams. Each team, as I said, will have 5 minutes to make their pitch, and then there'll be 5 minutes for the judges for Q&A. After the pitches, then we'll have the 30-minute intermission that I already talked about, and after that, the awards will be announced. $2,500 for the first place team, $1,500 for second, $1,000 for third, and then $500 for the People's Choice. So I hope that the people voted for the People's Choice. Make sure I didn't get this page flipped around here. Okay. All right, I think I've got the right page. I apologize for not knowing which page went where. So please keep in mind that the first place winner will automatically advance into the DifferenceMaker preliminary pitch-off this spring for a chance to win a portion of $50,000 in funding. So this is an additional bonus. So I wish luck to each of the teams this evening. Keep in mind that there are microphones on the podium, a wireless microphone, and a laser pointer. Although, Tom, did you say there were some challenges with the laser pointer?
Yes, they can try to use it, but it was working earlier, but it's not working.
Okay.
Sorry about
So I find that a finger works really, really well. So, frankly, I like a finger better than a laser pointer. Because with laser pointers, people tend to do this. So if anybody's using laser pointer, you know, don't be circling like that. You just point right to it and stop. So that's my advice for you in giving presentations this evening. So David, right over here, will alert you at the 1 minute remaining mark and when time is up. Now for the finalist teams in pitches. In no specific order, here is the first team pitching this evening, and that team is going to be MOCLAB. So please come to the stage.
Hello everyone, esteemed guests, final judges, professors, and family members, contestants, thank you for coming to the DifferenceMaker competition. Unfortunately, my team member, Joseph Nguyen, couldn't make it today due to bereavement, which is really unfortunate. He really wanted to be here. So, MOCLAB, our engineering team for the engineering prototype competition is designing custom drones built for commercial and recreational pain points. So I'm going to start off talking about the introduction with the team members who are involved in MOCLAB. We're going to go through problem definition, some of the customer pain points that we're dealing with. We're going to go into some research and market, and really just go into what this product is about. What is MOCLAB achieving? Introduction and team. I'm an electrical engineering graduate student here at UMass Lowell, and technical advisors for this project were Professor John Francis Mithlier, one of the technical advisors who worked alongside Orlando Arias, another associate professor who really, helped our project, help our team build this prototype and begin working with some of the customers. Joseph Nguyen is a software engineering student at UMass Boston, who's planning to do his PhD at UMass Lowell upcoming. So some of the pain points. One of the biggest problems that we're facing when it comes to drones that are on the market, over-the-shelf components, is a lot of these drones are being operated with an operator, which is no problem. But with these over-the-shelf, with these on-the-market drones, they're not that fast. They don't really deal with a lot of the pain points that customers have. They're really built for recreational purposes. And with the advent of international conflicts, with what's going on in the world, the United States has just recently banned 7 of the top Chinese drone manufacturers. So a lot of the competition and a lot of the stress now within the United States is about manufacturing and building drones within the United States using components that are manufactured in the United States. Like I mentioned earlier, 63% of these registered drones are really just being built and flown recreationally. There are a lot of hobby drone flyers, a lot of people who use these for their own personal use, whereas only about 36% now are used for commercial purposes. This includes agriculture, this includes construction sites, this includes terrain mapping for utility grids. And by 2030, the statistics are indicating that the drone market's going to reach about $55 billion. It's steadily compounding annual growth rate. And now with this blacklist, with the CHIPS Act that Joe Biden has recently, published, there's a big emphasis on companies now, especially American companies, to manufacture drones using components that are, built in the United States. The market. So a lot of these companies are outside the United States. These are not in order. These are ranked companies based on how well their drones are. So the first one being Zipline, and many of these companies in the United States are doing it for agriculture, for mapping, inspection, which is great. The market, at the moment, with DJI, Parrot, non-US companies leading about 75% of the growth. They're selling a lot of their drones, but now, we're dealing with problems where we can't buy these drones anymore. Parrot drones, DJI drones are not available anymore. They can't be used for commercial purposes. They can be flown recreationally, but they can't be used for tackling customer points. So what have we done? Joseph and I have actually built a custom drone. This is our Titan 1 product. We went through about 7 different phases of prototypes. It's about 1.5 years worth of work with the registered FC, flight controller IDs. These are registered, reaching about 148 miles an hour. So these drones were built for chase purposes. Super fast drones with about a 7.5 minute flight time. So we reached 0 to 100 miles in about 2.5 seconds. We're quite inexpensive compared to on-the-market solutions. We're selling this about $550 to about $599 at the moment. We sold about 15 units so far. We've recently discussed, a lot of things with NVIDIA. We want to get their GTX2 module to fly our drone autonomously, so that we can address these customer points and to be used within different applications like search and rescue. So, the biggest reason why we built this drone was to be used for search and rescue, hitting top speeds to cover a lot of land in a quick amount of time.
Time's up. Question and answer
Yeah.
time.
So open it, just the question and answer from the judges.
You said you sold some drones. Who are the buyers?
So a lot of the units that we've sold, the clients that we have are sold for recreational purposes. We've garnered a lot of attention online, for building a really nice drone that's really quick. We custom tailored these to have CADX Vista and FPV goggle sync with our flight controller. So a lot of people are flying these, outside, just for hobby purposes or just to be able to utilize how fast it is.
You mentioned the current drones are not very fast.
Right.
What's the speed of the current drones?
DJI, so the Mavic drones, they're quite expensive. They're also hitting high numbers, but a lot of the drones that currently exist on the market, Parrot being one of them, a lot of non-known companies are hitting about 80 to 90 miles. DJI is one of the top competitors. They're hitting about higher speeds, but their drones are also quite expensive. But they're able to, cut those costs down for manufacturing within China.
And besides speed, what is your advantage versus the current?
So the biggest one at the moment is, for all of our clients, is we're building these drones custom built for them. So within our website, and meeting with clients, we tailor these drones specific to their needs, custom design, whatever that they are planning to address. We have 7 different drone variants, meaning 7 different frame variants, 2 different flight controllers that we own, that we're looking to get a patent on. And the other thing too is everything's been assembled, everything's been manufactured within the United States. With the CHIPS Act, with a lot of these semiconductor pushes and a lot of these compliance issues and safety regulations that are in place, it's that trust that we can build with the clients first and foremost, alongside the product.
So I was curious, how are you, as you're building this out, addressing potential security, safety, and effectiveness concerns?
That's a great question. So, the first point that we addressed was, for any of these flight controllers that we're buying, we're registering them, hitting all the compliance standards, meeting all the compliance, the hardware technical, compliance statuses for those. The second thing is, one thing we're going to plan to do with the phase 2 funding is to ruggedize these boards using underfill techniques to make sure that people who get access to these flight controllers, to these specific hardware, can't really take out any of the components, can't reverse engineer any of our hardware.
Okay, and is there a particular market that you plan to focus on first? You mentioned search and rescue. Is that where your focus is in the beginning?
Our Titan 1 product is tailored to that. That was our initial design. Our prototypes are super flexible. We can design our drones to meet different needs. So we're starting off with search and rescue. We're planning to do different ones like agriculture. We're planning to go into industrial, so terrain mapping, mapping within construction sites. And there were talks about there were discussions about DoD applications for this.
Thank you.
So what's your next step in prototyping?
Yeah, so the next step that me and Joseph discussed was, we already discussed with NVIDIA to get a GX2 module to fly this drone autonomously. Currently, commercial application and recreational applications a person has to operate this drone. They're flying it with a controller. Typically, they have an FPV or first-person view goggle with their Canex Vista, so they're able to see with the drone. The next step, with the funding, would be to fly this autonomously, and then after that would be to cover those security points that you mentioned about ruggedizing.
One of the applications you mentioned was around medical delivery, I think in your write-up.
Right.
So that's really interesting to me, coming from the pharmaceutical industry. There's certainly a huge need for things like, how do we get organs, that are being transplanted or need to be transplanted, and this time is of the essence. And so, any thinking on that?
So there's a lot of, with those, there's a lot of compliance, there's a lot of standards that are put into place, there are a lot of requirements there. So if we plan on going into with pharmaceuticals or with the hospitals, it's not something we're going to address immediately, but if we get approached by them, we're more than welcome to definitely cover those points.
Work out the bugs first.
Work out the bugs first.
So unfortunately, the time is up for question and answer.
In order to prioritize neurological health and safeguard against traumatic brain injuries such as concussions and CTE. We were previously awarded with the Enterprise Bank's contribution to a healthier lifestyle award last spring at the 2023 Idea Challenge.
Right, so current concussion procedures consist mainly of visual assessment by coaches and medical staff. Despite their extensive training, it still has its inaccuracies, and this is due to many environmental factors. One being, this relies heavily on the player's ability to self-report their concussions, which I hope you can understand many players feel a pressure not to do. Right? And because of this, there are a large portion of a significant amount of concussions that go undiagnosed, and a significant amount of players who develop CTE. And so the purpose of this product is to recognize a concussion before or immediately after a concussive event using quantifiable data, which is currently lacking. And roughly several million concussions are diagnosed annually. And we've done some extensive research on this, and we found in an online survey, 85% of athletes were not aware of all the symptoms of a concussion. And in a 27 in-person interview assessing parental knowledge, attitude, and practices, we found that when we asked parents how many concussions they believe went undiagnosed, they answered roughly 20 to 50% of concussions go undiagnosed. This was further reinforced by a quarter of parents believing that their son had sustained a concussion that was never diagnosed.
Our competitors we found to lack in three essential aspects. It's versatility, as they cater exclusively to one sport, narrowing their outreach on such a large market. They utilize advanced analytics that require professional inspection and judgment in order to gauge injury severity, and they fail to accommodate to the price range of their primary consumer base. So Neuralize has discovered a way to adequately address each of these concerns. So our device continuously monitors and tracks impacts that individuals endure in contact sports and activities, and quantifies this resulting trauma in a force equivalent metric, that of which is used in modern day injury analysis. The data is communicated through a user interface that displays analytics and notifies the user when a safe threshold is exceeded. We designed this to be universal to a wide range of sports and activities that utilize protective headgear. The price, yes, back to one back. Yes, we made this so that our price accurately reflects the accessibility that individuals deserve to monitor and protect their mental and physical health, and we prioritize ease of use and comprehension while facilitating the administration of medical aid. Most of our funding would be allocated towards the predominantly high upfront expenses that have to do with polycarbonate injection molding. These are later offset by low per unit costs, but other fabrication methods proven to produce inadequate strength and intricacies which we need with this product. With better material fabrication process, we can move on to more rigorous testing procedures, that of which will be used towards certification efforts. And then we'll be making overall improvements to our design, primarily pertaining to the internal components and integrating and reducing the size of those and making them more capable. This entire funding package will allow us to drive the capability of our product in order to lobby for more investing. Pictured here is a slightly outdated CAD rendering of our first prototype, that of which has been iterated on several times since the screenshot. There's a removability feature that's not pictured here that will allow for the removal of the product for recharging and helmet changes, Bluetooth compatibility, and a 9-axis inertial measurement unit that measures linear and angular acceleration in X, Y, and Z planes. This is our working application that will track it in real time and also reports internal operating temperatures and humidities to ensure that the product is not overheating. We have a summary page that shows maximum G-forces experienced, and we're working to incorporate more algorithms on the back end to present more data that will help the user to understand the impact that they actually endure. Thank you.
So just to be clear, I understand your proposal. You have a device that people can apply to existing helmets, or?
Correct.
Okay.
Yes, so we want to make this applicable to a wide range of sports helmets, so whether it's a football helmet, skiing helmet, if you put a lacrosse helmet, we want to make this internal or external to the helmet. There's some liability issues that have to do internal to the helmet, but we made this durable enough to be placed on the outside.
Quick question about your testing protocol to ensure, accuracy of data, accuracy of test results. What are you doing for that?
It's primarily been finite element analysis right now, since we're in the early stages of the prototype. We're working to determine what standards are currently being used in sports, such as NOC standards, to know exactly what value that we actually have to be able to withstand and measure up to be able to be certified. We've done some drop testing and temperature testing to ensure that the product's not overheating inside, and then just in some interest testing to ensure that we're not getting any water or dust inside of the enclosure. But it's primarily impact testing to make sure it will be able to withstand the forces it's going to be subjected to, whether it's from a fall or from being tackled by the player.
Okay. Just really quickly, do you expect to have to go through any regulatory pathway based on the type of results that you're going to be generating? Or is this going to be just more, so it's not a real diagnostic product, but it's more of an indicator?
Mostly an indicator, yeah. So we're looking to define a threshold to recommend for people. So if it exceeds a certain threshold, a user would be notified to come off the field and go in a concussion protocol, or you can use this data and bring it to your medical professional so they can help to diagnose you, since a lot of these are going undiagnosed, and these undiagnosed concussions accumulate on top of each other, and that's how people are getting CT.
How much do you estimate this device will cost you to manufacture, and how much do you estimate you will retail it for?
Yeah, so we've had a little bit of conversation about this. Even with these somewhat expensive electronic components that we're using outside the hobby market right now, we're able to make this for $50, but we know if we downsize this and we get a manufacturer and a supplier on board, we can probably get this down to at least half of that. The sensors itself and the PCB board is relatively inexpensive. As I mentioned, the most expensive part of this is the expenses that have to do with polycarbonate injection molding and creating a mold for that, and a supplier for that. So that's what we're focusing on right now, since that will drive our testing results and be able to prove the capability of our product. Our competitors right now are selling for at least $300, so we're hoping to get this down somewhere about half of that. We really want it to be a price that adequately reflects the accessibility that people should have to be bonded.
And do you envision consumers will buy this themselves and apply it to helmets, or do you envision selling it to the sports team? Can you tell us a little bit more?
Yeah, we've explored two different pathways, so it's business to business or business to consumer. There's different ways, it's a more contractual obligation if you're going with a business, like selling to a sports team or an organization. It's better for sales since you know you have like a contract attached to it, and that you can sell it to a lot of different players. But that doesn't address the people who are using this for motorsports, mountain biking, skiing, or snowboarding. So we also want a pathway that allows people to use this if they don't compete, in contact, like a team sport. So they can use this if they endure a fall, if they're learning to ski or something, and they can use that data to bring to a medical professional to get a better idea about their neurological health.
Is there a particular force or impact that they need to reach in order to say, oh, maybe I've been diagnosed with a concussion, or the probability of a concussion?
Yeah, great question. There's a lot of research that's been done about this, but there's also a lot of gray area because every hit is different, everyone's brain is different. So while Elliot has done a good amount of research to try to define that threshold, it's something we want to recommend to users so they can actually use the data that they get and bring it to a medical professional if they do receive a significant impact. Although this exact threshold, it's going to be different for everyone. 2 hits can cause a concussion for somebody, but not for somebody else. But just providing access to that data, because especially for like linemen in football, smaller repeated impacts can also cause concussions. So just having access to that.
Could you also utilize it in cars somehow, like to detect in a car crash if someone may have a concussion?
That's certainly an applicable market. It's actually, these same sensors are used in vehicle impact testing in crashes, so to deploy airbags and whatnot. It's really about just measuring that acceleration, especially for something like whiplash, and that's what's most pertinent in injury analysis, especially as it pertains to the head region. So it's something we've thought about. We've stuck to sports that utilize protective headgear. Using something without a helmet is a little bit more difficult right now, but we're working to incorporate that. So thank you.
You guys probably saw the salt-littered road outside. I'll introduce myself. I'm Joshua Landis. I'm a mechanical engineering graduate student here at the University of Massachusetts, presenting Spark Cell today. It is my intention to bring elemental analysis to a whole new form factor. Old-fashioned way. Anyways, back to salt. It likes to break stuff. It likes to find its way into pores of concrete and asphalt and embrittle it, make it not last as long, accelerate deterioration, and further jack the oxides that are inside of supporting rebars. This is a huge problem that's caused by, 1, the salting of the roads, and 2, the deliberate addition of excess chlorides into concrete that cause it to harden faster, making a job cheaper for contractors to do. So what's needed is a way to inspect these salt and chloride levels in the concrete and do so in a rapid, handheld fashion that can be deployable and scalable. With the recent bipartisan infrastructure law allowing billions of dollars into the reconstruction of bridges and roads in the United States, the market for bridge testing is expected to expand from a $200 million market to a $1.18 billion market by 2028. And the current testing methods that are being used is coring, which involves drilling out a cylinder out of a bridge and then crushing it mechanically in a lab a few hours away from the existing space. Obviously, you cannot sample an entire bridge using this method because it would be very costly and detrimental to the structure of the bridge. So, what's needed is a new testing method that isn't nearly as invasive or time-consuming. So, under some preliminary investigation, I wanted to see if I could tell if I can diagnose this cement using the elemental contents that are available in it. So what I did is I added a ton of chlorides to one of the samples and kept one as a control. And what I saw here is an increase in the number of chlorides that are visible in visible spectra. Now, the spectra is produced when you excite your sample enough to release the atoms out of the molecules and let radicals be broadcast into a sensor. This is a corroded sample here on the left, and this is a control sample here. You can see there's elevated sodium and calcium chloride, which are the result of deliberate addition of chlorides by me into the sample. But you can't just bring a $150,000 spectroscopy setup out to every bridge. So what are you supposed to do? Meet Spark Cell in the updated version here. The premise of the device is that you can take a small sample of the concrete instead of an entire core and sample it on site. Simply take your drill, put it through the concrete a few inches deep, making sure that you don't get any of the corrosion, getting any of the salts that you would have otherwise on the surface due to road salting. Put it in the device right here, and then sample it, producing characteristic emission from the sample. This spectra is analyzed by splitting up the light using a diffraction grating and sends that light to a camera for further testing. It can be used to detect the ratios between calcium chloride, calcium, and sodium, and iron, which are all indicators of excess embrittlement and oxidation in the concrete. Compared to conventional methods such as core sampling, it's a lot faster, it's less time consuming, well, it's cheaper too. Oh, sorry.
Time's up.
Have you filed patent?
I have not filed a patent yet now. Apologies.
What is your confidence level on this particular product so that you, versus control? So in other words, how confident are you that you're going to determine a bridge is rusted versus one that's not?
It would be a simple analysis of, can I see a sharp iron spike with reference to my calcium level?
Okay, so you see that. So now
pretty-
what's your confidence level on that?
My confidence level is pretty high.
Statistical confidence level we're talking about.
I would say 88%. With the current stage of the device, I'm not very confident. What I need is better optics. I need better collimating optics, and I need a better spectrum. And that's really what I'm here for today, is I'd like to raise some funds to make this spectrometer behave like the ones that you see in labs. But for these finite wavelength spectrums, obviously it'll be a lot cheaper if I can focus in on the vital wavelength regions than go for a massive broad region like in a laboratory instrument.
Can you detail how you'd spend the funds if you were to receive them?
Yes, specifically, there's not a lot of light being well focused on my camera sensor. And a camera sensor, I'll be honest, might not be the best thing for analyzing the spectra. So I found a CCD array, which is a type of light sensor, but in an array that's shaped like a line, and it collects light over a longer area, which might be well suited for this application. In addition, I can buy focusing mirrors that'll extend the path length of the light so that I can have a better opportunity to focus onto a proper sensor.
I have a quick question about just the broad application of this.
Yes.
I mean, this is a pretty interesting device and analysis tool. And you're only in the prototype stage, but have you started to envision, who's your customer? What's your go-to-market strategy on a product like this?
Yes, so I'm planning on selling this to municipalities who want to get hold of the new infrastructure funding. And they can legitimize the need for these expenses by inspecting their bridges using the device and using that as a claim to accept the funds. In addition, private companies are also interested in investing in the technology because they'd rather have on-site testing, one of which is Benon Engineering in Connecticut, of which I was able to procure some of my samples from. Thank you.
How much would you charge for this? How would you do the services with us? Would you take these and do it yourself, or would you sell the device, and how much would you charge?
I would sell the device. My whole goal from the beginning was to have an easy-to-use device. I would like to sell this for under $1,000, but realistically, I can see it approaching $1,300.
And how much does it cost you to make one of them?
I built this for $14. But with the optics that I need to prototype it, it could easily cost $100, $200. But the great thing about optical materials is they scale in cost. If I want to buy one mirror, it'll be $50. If I want to buy 100 of those mirrors, it might be exaggerated, but it could be $51.
I think Cindy touched on this a little bit. It's an interesting device. Have you thought about other applications?
Absolutely.
Yeah.
So there are all sorts of materials that can be tested. One of the things that I was working on with this elemental spectroscopy was actually medical applications. Now, I think this would be horrible for medical applications because it's really focused on solid materials. But there's tons of other solid materials. One of the biggest markets actually is alloy identification. So if I can tell the trace element concentrations with respect to, say, aluminum, I can separate 2024 aluminum from 6061 or 7075 very easily, which would be really vital if you're making a load bearing component, for example.
Last question.
Thank you.
Yeah.
Again, this is Architect Solutions. Thank you to our team. Thank you to Professor Neri and Professor Gill already. So first is our problem. Most modern smart home solutions, they collect user data and they're implemented insecurely. Okay, so this means things like Alexa or Google Home, they take the data that's from around your house and ship it off to their own servers. This doesn't seem like that much of an issue until you look at what those companies might do with that data. They can sell this data to other people and to other companies that might be marketing or even call centers, and their servers can also be hacked, and that means that your data can fall in the wrong hands. Most smart home solutions, the actual device themselves, are also very poorly implemented. This means that when you put this device onto your network, it basically creates a hole in your network that people can spy into. So some smart home devices like cameras or baby monitors or stuff like that are implemented so poorly, you can actually just type in one command on a computer and instantly view what's on them. Finally, most smart home companies do not have the trust of their customers because they're basically just giving you a black box and saying, just trust us. And we want to change that.
Now, we wanted to make sure that our product would actually be welcomed into the market. So we did some research. We started off with a market survey where we had outstanding results. 81% of our respondents listed security as a feature that every smart home system should have. And 50% said that they were actively concerned about the existing security of their smart home systems. We continued with some of our own statistical research. What we found was that in just the first 2 months of 2023, there was a 41% jump in the average number of cyber attacks on smart home systems compared to all of 2022. We also spent some time with the cyber defense team here at UMass Lowell, where there were some graduate students who had recently done their own extensive research on the security of existing smart home systems. What they told us is that there are few, if any, systems that are currently out there that even make use of the base level security features that exist. Lastly, we took a look at our competitors. Our biggest competitor would be Home Assistant, as they offer a solution to many of the security features or security risks that we have presented before you. However, Home Assistant falls short in two main categories. The first, it's not very friendly to use for any non-technical user. And the second, is that Home Assistant does not fully lock down the devices that it controls on the network. What that means is that there's still many chances for security risks within their system.
That brings us to our solution. So this is our prototype. We call it the Smart Home Firewall. This is the device that you will connect all of your other smart home devices to, and it will give you the ability to dictate what goes to your network and what does not. This will basically close the blinds, so to say, on people trying to look into your data. We also plan to have our own smart home systems. What Hayden is holding in his hand is our prototype Smart Plug, and this is a device that basically lets you turn things on from far away. Right now, it's just in the prototype stages, but we hope to have many more smart home solutions, like home assistants and switches and stuff like that. Second, we think it's very important that our consumers trust us. And this means that we're going to make all of our software and our hardware open source. We're doing this so technical users can look at our code and make sure that we're doing everything we can for their security. We're also going to make a website that makes it easy for non-technical users to look and see how their product ticks. Lastly, it's important that we offer a complete and easy-to-use system. Nobody will use our product if it's not easy to use. It's extremely important that we offer a very similar experience to other products while giving your security no compromise.
Now, as we all know, in today's day and age, nothing comes without a cost, and products like ours need resources and funding to go anywhere. We estimate needing around $5,000 to reach the next phase of our project. That money would go towards more precise equipment for better prototypes, tools to properly test any new feature that we may add, and towards our own cloud server, which, rather than storing your data, would strictly be used to allow you to control the devices from virtually anywhere. Lastly, we realize that for this product to work, we need to fully understand what our customers' needs and wants are. So a portion of our budget is going to go to continued market research and community outreach. Thank you for your time and consideration. We hope you're all having a great night so far. We'll open it up to the floor for any questions that you may have.
So my first question is really around, given your novel approach to solving this problem and this gap that exists with the current market players, what are you doing, or have you started to consider how you're going to protect this approach from being stolen or copied by the existing market players and leaders?
Yes, so although this is open source where everyone can kind of see all of our software, a big part of the reason we were doing this as open source is for the security features. So although other companies could take this and implement it, big corporations don't tend to like to put their software out there and how they write their code. So they can implement it and talk about how, our thing is secure now. But since ours is open source, users will be more likely to trust us and use it because they can see for themselves that it's actually being used in the proper manner.
If I may add to that, we're also using the GNU public license, which makes that anybody who uses our code must open source their code as well. So that means that even if some corporation were to take our code, they would have to open source it, which would kind of be furthering our goal anyway.
To sell a lot of devices, you would have to sell to consumers.
Right.
We need some kind of partnerships with the Comcast or somebody like that, or maybe Best Buy. So one of the reasons why these guys make money selling our data so that they can keep the device cost lower. Even if they're losing money on this hardware, they're making money and monetizing data. But if you're not doing that, you'd have to put this device price higher.
Either that or lower profit margins.
Yeah. So that's that could be a problem for us.
Yes. So the current plan is to have the firewall that Tyler displayed and 2 of these plugs. If we keep the current components that we have, we think we can have it priced for 2 plugs and a firewall around $70 to $80. We're hoping to get that down even less. And we think we'd still have a profit margin with that, as well as possibly selling it as a kit for anyone who wants to have like a build-it-yourself sort of thing, where they can build their own smart plug system and have everything within their house.
So
So as someone in the safety space, I'm definitely very safety conscious. So when I built my house, there are cameras everywhere, inside, outside, and one of my family's concerns was exactly what you were saying, privacy. How easy is it to hack into a Google Home, or is Google watching you inside the house? My one concern with you guys' project is by making it open source and showing your code, are you making it easier for a really good hacker to maybe work around your system? How do you prevent that?
So that's always a concern, but there are many open source solutions out there that are extremely secure. Linux, being one of the most popular operating systems, is open source, which means that everybody can comb through that system and find all the vulnerabilities. So as long as we open up our device to the market in a way that people enjoy and want to work with it, I think that we are going to have a lot of people who are seeing the good in our project rather than trying to destroy it.
So why not do the same exact thing, a more secure, more trustworthy, without making it open source? Why make it open source?
Personally, to me, I don't think I would trust a product like this unless I could see what the internals are doing. I think that that's part of the trust part, where we would be different from someone like Google, where we're telling you this is exactly what we're doing with your data, and it's your response. It's your. You get to choose what happens with your data, basically. So instead of us detailing that to you and just saying trust us, we're telling you this is how we're doing stuff, and then you can make your own decision.
I would definitely encourage you to ask that question when you do more market research, because I think it's a phenomenal idea. It's just still a big concern of mine, is I know so many savvy hackers, unfortunately, and that would be like the one thing that would stop me from buying. So I encourage you to ask that question during the market research to see people's different viewpoints, but great answer to the question.
Thank you so much. That was great feedback.
And over 90% of consumers are not able to look at the code and figure it out. So
Yes.
even if you say mine is open source, look at it, it's safe. Over 90% don't even care. They don't even understand. They only listen to what you say.
To kind of solve that, we plan to have like a forum on a website where we can have our technical users comment on like, yes, I've looked at this, I trust this device, and if we get enough feedback, like our initial target audience for like our first push is going to be a lot of technical users who would understand it, to then kind of gain that trust to then be able to expand our market to less technical people.
We also want to, Hayden mentioned we're working with the cyber defense club here at the school. I think later on down the line, it'd be great to be able to work with universities, with their cybersecurity departments, and have them try to attack our software. And then we can use what we've learned from those attacks to implement better. And then we can sort
I'm Jason Moose here. I'm a biology major.
I'm Sandy Durance, and I'm liberal arts with a focus in psychology and studio art.
And I'm Chiburo Masikoi. I'm a biomedical engineering major.
And today we are introducing ZipperBuddy, which is an adaptive device that allows you to turn any jacket into a Velcro device, one-handed opening for people with upper mobility issues.
Alright, so what is the problem? I mean, I'm sure it's snowing earlier today, and we all have to zip up our jackets and bundle up, right? And it's not necessarily that easy for everybody, unfortunately. Two hands are required to efficiently zip up a jacket and zipper teeth, and those with mobility constraints might find it difficult to zip up a jacket, if at all. So now we're talking about a zipper, which is a two-handed device, being inconvenient and a challenge actually to close. And so people with like musculoskeletal conditions, people with arthritis, children developing fine motor skills, and stroke survivors, like our patient who we're going to introduce to you guys, all struggle with these, with zippering up jackets as a result. So about 1.71 billion people suffer from musculoskeletal conditions, and in a broad survey conducted in the US of people over the age of 18, of the 19 million people, about 10% reported that they had trouble zippering and with mobility difficulties generally. And actually, we're talking about a broad population here. We're talking about 2 to 53% of individuals having upper limb mobility issues and difficulties. So it's a big need.
So this paper that we found does a really good job explaining the effects that can happen when people are not able to dress appropriately. So in the middle here, there's statistic 50% of respondents to a survey said they had to back out of the event and couldn't go because of difficulties wearing the proper attire. And the paper made sure to point out that in some cases there were long-term negative effects on personal relationships because of this. More stats to point out are 50% expressed concerns over seasonal clothing and job uniforms. Around 65% expressed that they felt embarrassed or humiliated because of clothing-related challenges. And almost 50% have difficulty using zippers specifically. So this project is part of a class called Adaptive Devices for Better Life, in which we are paired with an actual client and we hear their needs and we develop a product for them. So this was something that Bob wanted us to tackle. He had a stroke and he has difficulty using the left side of his body, so we wanted to develop something that makes it easier for him to wear his garments without having to use two hands to zipper. He said, dressing with use of only one hand is very difficult. I can't tie laces and do belts well, and clothes with zippers cannot be done. If jackets and vests have zippers, but finding these with buttons is proving difficult. Explored alternative sewn in, but it changes how these fit.
And going off on that point is there's a lot of adaptive devices on the market today that don't accommodate to a wide range of people. They are either deconstructive, so they take away material and the fits become too tight, or they are high expensive in costs, ranging from $75 to almost $120. And then when you get into magnets to make things close, then people like Bob, who have a pacemaker, cannot use them because it interrupts that.
Zipper Buddy is our solution. We are going to demonstrate it for you. Zipper Buddy transforms zippers easily to provide independence after a one-time installation, giving the user dignity when they're self-dressing. So you only have to get help one time. As you can see, it's being attached. We have zigzag patterning that helps to increase the ability to grip it for easy attachment. And it can be fastened with the use of only one hand. Unlike the other products that are deconstructive, this adds material. And so, yeah, it's in contrast. We're also looking at brand deals and things like that to bring aesthetics to Zipper Buddy so that we don't compromise the way that it looks or the functionality of the garment. We have a 7-phase plan to bring Zipper Buddy to market. Phase 1 is zipper research and testing. Phase 2 is fabric research and testing, and there's more phases. Thank you.
All right, let's have a drum roll here. So, we'll start off with the fan favorite. Okay, the fan favorite, Socket Tech. And number 3, in third place, is Spark Cell. And in second place is Socket Tech.
How do we do this? We everyone. Just want to thank everybody. It's an honor to be here. Thank you.
And in first place, Zipper Buddy.